first problem we're going to deal with is 5x equals 8, where we have to make x the subject. So I need this x to be on its own, and it is not. It instead has a times 5 with it. So I need to get rid of this time by 5 in order to make x on its own. The opposite of times by 5 is divide by 5. So when I move it to the opposite side, in order for these to be equal, I need to make sure that it does the opposite operation. So it's times by 5, so it needs to be divided by 5 when it moves to the other side. So here you can see me write the 8 I've kept the same, but I now have 8 divided by 5. So x is equal to 8 divided by 5. And that's the solution, just to move it to the opposite side. And the construct that we're going to consistently do here for this type of algebra, to keep things simple, I know you can consider it as divide by 5 on both sides, but we're going to move it to the opposite side, and the opposite of times by 5 is divide by 5, which is what produces this result. That's the discourse we're going to use for this point at the moment. Okay, so let's therefore apply this to 5x plus 3. Let's see, what do we need? We want to make x the subject, so it's x that we want. You would perhaps consider timesing by 5 as the most important operation because of such things as BIDMAS that we've been taught. But really we want to do the opposite, just like when moving things to the opposite side, we do the opposite operation. We're going to do the opposite of BIDMAS and look at the plus 3 first. This plus 3 here is somewhat confident. Let's move it to the opposite side, reduce its self-worth a little bit. Plus 3 needs to become minus 3. So as a result, you can see that I have to write that 8 take away 3 is now 5 times x. As we look at 5 times x, we can say, well, this x is what we want, so we need to get rid of this 5. And how do we do that? Well, it's 5 times x, so just as before, we need to move it to the opposite side. So we're going to move the 5 to the opposite side when it's going to become divide. It's going to become divide by 5 here. So you can see that is what has been written underneath. Finally, that x is equal to 8 take away 3 divided by 5. 8 take away 3, of course, is 5, so 5 divided by 5 would leave us with a final answer of 1. And so the solution is that x equals 1. And if we look back at this scenario, we can see 5 times 1 is 5, plus 3 is 8, so that's true. And so this pattern seems to be working quite nicely. Finally, let's take a look at this one. X is equal to, x over 5 is equal to 8. We need to get rid of, therefore, the divide by 5 because we want x on its own. Remember, the goal here consistently is to make x the subject. So if I move divide by 5 to the opposite side, we perhaps should be starting to find the pattern in that it should become times by 5. So 8 times 5 is therefore 40, and so the solution is that x is equal to 40 because I took divide by 5, moved it to the opposite side and where it became multiply by 5 and did the algebra. And just to check, if we take 40 and we plug it in, 40 divided by 5 is 8. So it is true that x is equal to 40. Let's take a look at 5x plus 3 is equal to minus 8. Not exactly what some individuals that are following my course have seen. It's a little bit different to what we've discussed in the past, but at the same time it's very good practice. So 5x plus 3 is equal to minus 8, and as a result what I'm going to do is I'm going to take this plus 3, like I said before, you don't want to deal with the multiply first, you want to think of it opposite to BIDMAS or BODMAS, depending on the background you've had in terms of mathematical teaching. Plus 3 needs to be moved to the opposite side where it will become minus 3. So I now have minus 8 take away 3, which is minus 11. So I have minus 8 take away 3, which is minus 11. And now all I have to do with is the 5x. And 5x can be dealt with quite nicely, similarly to before. Really, I know that I need x, and so I need to move this 5 to the opposite side, in which I can do so by suggesting that the 5, when it goes to the opposite side, will be divided by 5, which is why you have minus 11 divided by 5 when you finally have x, which can be written quite simply as x is therefore minus 11/5. Going forward, another problem is 5x minus 8. This is a good problem because it makes us consider minus signs somewhat. So how do we deal with this? First of all, let's start by making it clear what we desire. We want x to be the subject. So I'm going to put a box around that and say we need to get rid of, therefore, this 5 first. And you can see that is done quite smoothly. I move 5 to the opposite side. It becomes 8 take away 5 because it was plus 5 before. It was positive 5 before. And so as a result, when it moves to the opposite side, it becomes minus 5, leaving us still with this minus x. As you can see here, this is minus x, so it must be minus x when it is left on its own. So minus x is equal to 8 take away 5. 8 take away 5 is 3, and therefore we now know that minus x is equal to 3. So let's say, as a result then, if minus x is equal to 3, we can perhaps consider the idea that x therefore must be minus 3. One way to think about that further, if you wish to, is considering what happens if you substitute minus 3 in here. It'll be minus minus 3, minus and minus is plus, so it'll be 3, and so 3 is equal to 3, which is true. So therefore the answer, x must be minus 3 for this to be true. So x is minus 3. And another way to think about it, of course, is a simpler mechanism is to realize that if minus x is 3, then x must be minus 3. But substituting the value in makes it logically, makes us able to view it in a more logical manner, perhaps. So let's take a look at this next one. The next one we're looking at is 5x plus 3 divided by 2 is equal to 8. The thing that tends to cause issues with this one is the fact that when you're looking at fractions, it might be wise to consider the numerator as one whole structure and the denominator as one whole structure. And then what you're considering is not really about the plus 3 and the 5x, but really about the numerator and the denominator. So if I want to get to x, let's not forget the goal. We must keep our eye on the vision. The vision is to get x on its own. If I want x on its own, I need to get rid of this divide by 2. I want it so that it's a nice, simple, flat, normal algebraic structure similar to this one here or this one here where you have 5x plus 3 equals 8. So what I'm going to do is I'm going to get rid of this divide by 2. And so in order to get rid of divide by 2 and move it to the opposite side, some might say we do times by 2, which is exactly what I've done here. So 5x plus 3 divided by 2 becomes 5x plus 3 is equal to 8 times 2. And 8 times 2 is 16. And so 5x plus 3 equals 16 is something that we now have to sort out in terms of respect to trying to get x on its own. But this is a lot nicer to deal with now that I've got rid of that divide by 2 and moved it to its opposite side. A lot nicer to deal with, to the degree that I can simply move the plus 3. I can simply move this plus 3 to the opposite side, which I can do quite comfortably because plus 3 would become minus 3, and therefore 16 take away 3 leaves us with 18. And as I've shown multiple times, and I'm being very repetitive here on purpose, that the 5x I can sort out in terms of getting x on its own, because multiply by 5 simply becomes divide by 5. And so x is equal to 13 over 5 in this one. Let's take a look at this next challenge with regards to rearranging equations. I'm looking at the idea of 5 minus x divided by 4 is equal to 8. I'm going to do exactly the same thing. So I'm going to look at this as the numerator and the denominator. And when I do that, I can see that yes, I do want this x on its own, but what is most important is to realize that I need to deal with the fact that we have a fraction. So let's remove the fraction by removing this divide by 4 here. This divide by 4 must get out of one's face, and so we have to have divide by 4 becomes 8 times 4, because divide the opposite, when it moves to the opposite side, it must be times by 4. 8 times 4 is 32. And we're still left with this 5 minus x. There's been no change there. There cannot be. We haven't done anything to it. So 5 minus x stays 5 minus x all the way through. But we have 8 times 4, which is 32. I'm now going to deal with this 5. Let's not forget that this 5 is meant to be plus 5. And so plus 5, when it moves to the opposite side, is minus 5. So you have 32 minus 5. Minus x equals 32 minus 5. I'm not sure why I've done this twice here. Some might say it looks a little bit odd. And it is, because I'm not sure why that exists. But 32 minus 5 is equal to 27. And similarly to before, if you have minus x equals 27, then x must be minus 27. And one way to make sure, or to be comfortable with that construct, is to substitute it in. It'll be minus 27, and minus make positive. So it'll just be 27 is 27, so x must be 27. Another way to do it is to consider the idea that if you take the original formula and you do 5 take away 27 divided by 4, you will have 8. And so it is true that this construct or this pattern works to find out that it works to find out what x is, and x is minus 27. So let's take a look at this one here. This one looks like it might be a little bit more challenging, but bear with me, it is similar. We have a 1 over 5x plus 2 is equal to 8. The first thing I'm going to do is, again, analyze this in terms of brackets. Now, what I mean by that is the numerator, assume there's some brackets around it, and the 5x plus 2, assume that there's some brackets around it. In other words, a pure numerator as one object or concept, and a pure 5x plus 2 as one concept. And so what I want to do is remove the fraction to make it less complicated. So what I'm going to do is not say what I'm going to do one more time, because that would probably cause some sort of level of annoyance. But anyway, 5x plus 2, when it moves to this opposite side, is divided by 5x plus 2. So of course it's going to be times by 5x plus 2 when it moves to the opposite side. And I say that one more time. It is 1 divided by 5x plus 2. So when it moves to the opposite side, it becomes times by 5x plus 2. I then can do the expansion of brackets, 8 times 5x, which is 40x, and 8 times 2, which is 16. And then I'm left with that. Remember, the numerator was 1, so I cannot change that. I've done nothing to that numerator. Numerator is 1, numerator is 1, numerator is 1. The only thing that might be wise is to recognize that I want x on its own. And so if I want x on its own, the main thing I need to do is remove this plus 16 here. So plus 16 is going to go to the opposite side. I'm going to move this plus 16, and therefore it will become minus 16 when it has the opposite side, when it's been moved there. 1 minus 16 is minus 15. And then the last part, which hopefully we're starting to get very comfortable with, to the degree it's probably somewhat annoying, is how do I deal with 40 times x, or any number times x? Well, when it moves to the opposite side, given that we want x on its own, it will be, instead of times, it will be divide. So I'm going to move times by 40 to the opposite side, where it should become divide by 40. And you can see that's exactly what's happened here. I've got minus 15 over 40, and perhaps that could be simplified down, but 1 is being quite lazy, so x is equal to minus 15 over 40. Now, let's take a look at I. I is a nice one. I is simply that 5 minus x is equal to 8x. The reason why it's nice is because it makes us consider negative numbers again. I'm simply going to do something that is definitely worth doing consistently in these scenarios, which is to try and bring the x's together. Some would even say, and I think they would be wise to, that if you don't bring the x's together, you cannot solve it. But you can use numeracy to figure out what 5 take away x is when it is equal to 8 times x. What could that number be? But many of these, in these situations, it is about rearranging equations, and sometimes you can have very difficult fractions. So let's go through the pattern. Step 1 is to recognize that it's plus 5 here. So when I move that 5 to the opposite side, it would be minus 5. But that's not what I'm going to do. If you remember correctly, I said instead the main thing we want to do is we want to bring the x's together. We want to bring them together. And how do we bring them together? Well, really, I need to move this x here, this minus x, to this side. So it'll be minus x plus x, because the opposite of minus x is plus x, and I've got 8x plus x. 8x plus x simply produces 9x. And then we're at this pattern again, where you have an x times 9, and the opposite of times by 9 is divide by 9. So you've got x is equal to 5/9. Let's see if we can apply what we've learned with regards to this problem here. This problem is a little bit more interesting. You've got 1 over 5x is equal to 1 over 8x. The first thing I would do is remember that in these circumstances you want to get rid of the fraction. You've got a numerator and a denominator, and you want to consider them as concepts that need to be moved around. You've got a 1 in terms of the numerator, and a 5 minus x in terms of the denominator, a 1 on this numerator, and an 8x. So to get rid of the fractions, we really just need to get rid of the denominators. The first thing I'm going to do is get rid of this 5x here. So what I propose is that this 5x goes to this opposite side over here. So the 5x I want to move to the opposite side. It is 1 divided by 5x. The opposite of divide is times. So actually it will become, instead of divide by 5x, I would end up with, instead of divide by 5x, it will become, let's put it here, multiply by 5 minus x, 5 minus x. And so really, how do I do that? I simply realize that the 5 minus x moves to this top part here to produce 5 minus x times 1. And 1 times 5 minus x is just 5 minus x. So that's why this has happened here. It is simply the idea that I've decided to take that denominator and change it from divide by to the opposite, which is times by. And so I end up with this 5 minus x times by 1. Remember, there is a hidden 1 times 5 minus x here, but there's no point in multiplying something by 5. So therefore, I'm nearly done, but the problem still is that I have another fraction, so let's deal with that fraction. The best way to deal with that fraction, remove it. Let's get that 8x and move it to the opposite side. The opposite of divide by 8x is going to be times by 8x when I put it here, and that's what I've shown here. It would be 1 times 8x is equal to 5 minus x. 1 times 8x similarly is just 8x. I've not touched this 5 minus x. I do want to do exactly what I did in the other one, which is bring the x's together, bring those x's together. And so how do I bring those x's together? Well, minus x needs to be brought on the left side with its brethren, and 8x plus x is therefore 9x. 9x is exactly what we need to deal with. We're very close to getting what we want, which, let us not forget, is x made the subject. And so if I want x to be the subject, I've got to get rid of 9 times it, and the opposite of 9 times is, of course, 9 divide. Okay, so now let's deal with a couple of others. This part might be relatively simple. It's just a nice reminder of the numerical ideas behind this. A plus 24 is 39. The opposite of plus 24 is minus 24, so it would be 39 minus 24, which is 15. And you can test this, of course, always try and test this if you can. What does it mean? It means that 15 plus 24 is 39, which is true. Part 2, 39 is equal to b minus 24. Well, if I want b, I want to make the letter the subject, just as we've always been doing. If I want b on its own, I need to make the minus 24 disappear. So minus 24 becomes plus 24. 39 plus 24 is 63, and therefore you can see 63 take away 24 is 39. So that's b is equal to 63. Finally, with regards to this page, we've got 4c minus 10 is 26. So the first thing I would do, of course, is move the minus 10 to the opposite side. Minus 10, the opposite side would be plus 10. And then at this point, you see that we want our c. And the only way to get c on its own at this point is to get rid of that multiply by 4. So you get 36 divided by 4, which, of course, is 9. All right, so nearly there. Thanks for concentrating in the meantime. We have d minus 3 divided by 4 is equal to 11. This one's not too bad. Hopefully it's similar to the patterns we've been discussing. If I want to move the divide by 4 and I want to remove all fractions, so I want to move the divide by 4 to the opposite side, it becomes times by 4. So all I have, therefore, is 11 times 4, which is 44. Then the take away 3 becomes plus 3 when it moves to the opposite side, leaving us with d is equal to 47. And finally, it's just a little bit of bracket work here, because the brackets are fundamental. Remember the pattern, 3 needs to be times by x, and then it needs to be times by 2. 3 times x is 3x, 3 times 2 is 6, and so, of course, then we have 3x plus 6 equals 62, no change there. I move the plus 6 to the opposite side, giving 62 take away 6, which is 56. And hopefully by now, and if not, don't forget that practice makes perfect, especially with regards to mathematics. If I have times 3, when I move times 3 to the opposite side, it must become divide by 3. So it's 56 divided by 3 is what x is. Right, finally, let's do this last part. The last part suggests that we have the problem 4c minus 3 is greater than 10. Is 4c minus 3 greater than 10? Well, let's find out. So the first thing we're going to do, well, that was an odd question. What I really mean is, what is the value of c when 4 multiplied by c take away 3 is greater than 10? So that is to say, the first step is 4 times c, then 4 times minus 3. This is exactly 4c take away 12, 4 times 3 being 12, making sure it's minus, and there's no change to the right-hand side here, so there's nothing new necessary. The one thing, however, is that once you realize that you want c, because there's the letter that we're trying to make the subject in all of these problems, then you can see that if we're going to follow the same pattern, which is the opposite of bidmass, then we need to move the minus and plus first. So the minus 12 becomes plus 12, and then you have 4 times c. So you've got to, let's deal with this maths first. You can see I've done 10 plus 12 is 22, and then of course times by 4 becomes divide by 4, leaving you 22 divided by 4, which I'm sure you can use your imagination to simplify even further. So that is rearranging equations regarding finding the subject that is a letter. Thank you very much for your time. Take care. Bye-bye.